Is available now. Yeah, we are going live. Okay, so all set up. We are live now. Okay, so shall we start or shall we wait for a few minutes? Only very few. Okay.
There are very few participants on the WebEx.
Yeah, very few are there actually. Okay, so I think we wait for a couple of minutes. It's 9:58.
Yeah.
Okay.
Yeah, people are joining.
Actually, workshop में participate किया. It uses Python for competition.
Please
Yeah,
mute.
10 बजे का Wi-Fi is not okay. I don't. It is a 4 days workshop. I don't know because too early I had filled. Yeah, I had filled a form too early. I had asked to fill it.
Amritsar, please unmute yourself.
Yeah, can you hear me?
I can hear you. Okay, so once you start presenting, I will mute everyone. But if right now I'm trying to
Yeah.
mute, then the person who is speaking is not getting mute, others are, you are getting muted. Okay, so shall we start now?
Hello.
Hello.
Yeah, we can start.
Okay, so I welcome all of you in this workshop, online workshop on SageMath. So all the lectures will be given by Professor Amritanshu Prasad. He is professor at IMSC Chennai. His research interests are combinatorics and representation. He has written a book on theory, combinatorics point. It was published by
Okay.
and Amritanshu Prasad has also contributed in SageMath. Now I hand over this session to Professor. Please.
Okay, so shall I start?
Yes, please.
Okay, so welcome everybody to the online SageMath workshop. I hope I can be heard. Please mute. I request all of you to mute your microphones. Yeah, there are one or two microphones which are not muted. Yeah, thanks. And so let's begin. So this workshop was designed mostly for mathematicians, particularly people working in group theory, combinatorics, and related areas. Let me just say that this whole Sage is it's designed so that you can learn it yourself. And the only thing I will try to do here is to facilitate and initiate this process so that you will be able to learn how to use Sage yourself. So if you want to know about Sage, the simplest way is to just go to the website of all the information on Sage and your tutorials and everything. So so there's download link here, the latest version. There's a start, there's help and documentation. There's the tutorial here which you can see, and it gives you basically, this workshop. You just need to spend some time here. But nevertheless, I will help you with some basic things, and sometimes it's just easier to have a guide for these things. Okay, so let me just start with the installation. I'm assuming that many of you have been able to install Sage. In case you haven't been able to install Sage, you can use this online version of Sage, which is called CoCalc. And cocalc.com, it's you can create an account here, and you'll be able to use Sage online, any setup at all. If you have a free account, then it may be a little slow, and eventually once you start doing serious things with Sage, you will want to actually install it on your own computer. But or you can also get a paid account here, which is pretty good as long as you have good internet connectivity. I like to use Sage on the command line. It's by far the cleanest and fastest way to use Sage. So I have installed Sage here on my computer, and I just type Sage, and I get it starts up, and now I can start using Sage. So I can type any command, and it works. But with the command line option, you need to be a little bit more familiar with Sage. And I think for most people who are starting to use Sage, the most useful way to use Sage is to use Jupyter notebooks. So if you have installed Sage, then you can start a Jupyter notebook by typing Sage -n Jupyter. Please note the spelling of Jupyter. It's Jupyter. Py stands for Python. And then it will start up a notebook server, and you will be able to use an interface which looks something like this. So this is an example of a Jupyter notebook. And both the command line option and Jupyter notebook are available in CoCalc. So you can create a new project. But if you have signed up for the tutorials for this course, then we have already created a project for you, and you are a student in this Sage workshop. And so there should already be a project for you, but nothing in as of now. So you can create a new project, and then you would be able to if you create a new project, you can give it a title, and then you'll be able to, it takes a few seconds to create a project, and then you can start running the project, and then you can just say new, and maybe what you want to do right now is say new Jupyter notebook. So you try this. Taking a little while. So this is a problem with, so you can, yeah, so you can create a new Jupyter notebook. So this may be the easiest way to get started here. So this is what I've done, and you can try to do the same thing. So when you start a Jupyter notebook, it will ask you to select a kernel. This is because multiple options are allowed. You just select the SageMath 9.2 kernel. Okay, and once you do that, you are in a notebook, and it has input lines, and you can type in whatever you like. And once you type an input line, it gives you an output. So, well, you have to, I guess, you have to click the run button, then it runs that line. Or you could just say shift enter, which is much faster, and it will run that line. It takes some time to get used to this notebook interface. I use just for speed and so on. I use the notebook interface on my own computer, and here I have already created a notebook which I will be sharing with you shortly after the lecture. Uh, so it's got, this notebook has got different kinds of cells. So this cell here, the first cell here is what is called a markdown cell. Don't have to worry about it too much right now. And these are cells. So if you click on cell, then there is cell types. There's code markdown and markdown. So those are the two kinds of cells I'm going to be using. You will just need to use code cells. I'm using markdown cells to explain various things and explain what is happening. So so here there is a typo here. I can correct it, and then so and then I press shift enter, and then okay. So to get Sage, visit sagemath.org. If you want to use Sage, you can use the command line interface. You can use Sage Notebook, or you can use Jupyter Notebook. And you can use these on cocalc.com. Now we'll just using some very basic features of Sage. Um, so let's see. So let's just see how to do calculus. It's pretty much everything you need is um, already built in here. So you can just start defining a variable like I want to take this quadratic polynomial x squared plus x plus 1. The variable x is already provided as a symbol. So if you type x, Sage knows that, okay, you mean the variable x. So here I just type in x squared plus x plus 1. So let me just clear this whole thing. So you can go to the kernel, restart, and clear output. Okay, so now this is a fresh kernel. There are no outputs here. Okay, so suppose I just typed in x squared plus x plus 1, and then I get here x squared plus x plus 1. So that means Sage has created this function x squared plus x plus 1. Now you can assign an expression to a function. So for example, you could say f of x is equal to sine of x minus 2 pi over 3. Sage already knows what pi is. You could say gx equals sine x and hx equals sine x plus 2 pi over 3. So you can try typing these things in. So you have now defined three functions, fx, gx, and hx. You can type in whatever you like, any functions that you like. So these functions you can use later. So for example, I can define a function ux to be fx plus gx plus hx. So that's one of the advantages of giving names to functions. So now once I click on this line has run. It has run second. This was the one which ran first. This one ran second, and now this will run third. If I rerun this again, this will become 4. So that means this has run after this again. So anyway, so these numbers here next to the input code input cells will tell you in what sequence the cells have been run. And this is one of the features of the notebook. It has this flexibility of running the cells in any order, and this is very convenient if you want to just experiment and play with code and so on. In the terminal interface, this is a little more difficult. So yeah. So here you just have a sequence of lines, and you cannot go back and forth. Though there is an up button where you can remember your previous your previous things that you have typed and so on. Okay, so now one of the things that while teaching calculus or mathematics, you would want to often plot functions. So you can just say plot f. So f, remember, fx is a function sine x minus 2 pi by 3. So we'll say plot f. We have not really specified much, and Sage will somehow automatically decide what range to plot it on if you don't specify anything. But specify things and so on. And so, for example, you could specify the range. You could say x min is pi and x min is minus pi and x max is pi. Okay, so then it will plot between minus pi and pi. But okay, this is very complicated, right? How do I know what are all the things I can specify and so on? Do I have to remember everything? And the answer is no, you don't have to remember everything. There is help available in line. So you type the command that you want to know more about and press question mark. And so you have plot question mark, then you will just see the help on plot. So it says, it tells you the basic syntax of the function. So plot, you can give a list of functions, you can give arguments, and you can give keywords. So it takes a little while to get used to the understanding how to read the documentation here. But here, for example, are the x min and x max arguments. So when you have something in these are optional arguments. So when you specify them, you have to say this is equal to this and this is equal to that. So you could also specify y min, y max. There are features like detect poles. There is the legend label. There's a whole lot of options here, and sometimes I find it easier to actually just go on the internet and use a search engine to look for examples and documentation. Very useful website is ask.sagemath. uh, what is it called? Ask SageMath, I think. Yeah, it's called Ask SageMath, ask.sagemath.org. And this is a Stack Exchange type of website where it's a question and answer forum for Sage. And you have pretty much any issue that you have, particularly, if it's not something too specialized, but also if it's quite specialized, you will find some help here. And the questions are voted up and voted down. So the good questions tend to get lots of votes, and you can search for questions on this. Usually just using a search engine to search for your thing will give you the right, will lead you to this website. So you can use the documentation using the question mark, and you can also use the internet to find out more about what to do. Okay, so you can also plot multiple functions in a single plot. So what you do is you put them inside square brackets and you separate them by commas. So remember here, up here we had defined three functions, uh, f, g and h. Go ahead and try these things as I tell you. Hopefully you're quick enough to type things. You may, I think many of you may have technical issues today being the first day. You try to sort them out after this lecture, and I'll also be sharing these materials with you. So, so now instead of plotting one thing, I can plot f, g, and h together. So what I've done is I've typed plot, and then these parentheses here are the arguments for plot. Inside this, so I put this square brackets and I type f comma g comma h. So this creates what is called a list in Python. It's a list with three elements, f, g, and h. And I say x min is minus 2 pi and x max is 2 pi. Now we do this, then Sage has automatically plotted all three functions in one single plot. I have not specified y min and y max. Sage has taken the minimum and maximum values of the functions in this case. And another nice thing it has done is it has also chosen 3 different colors for the plotting. And this is sort of the electrical system in my apartment with 3 phases. Looks like this. So you can and then you should just play with these things and um, see what you can do. But one useful thing is you can save a plot itself. So we had given the function a name, but we can also give the plot a name. So for example, I can say P is the plot of f from minus 2 pi to 2 pi. So now what is going to happen here? It will not draw this plot. It will just save it to something called P. And Q is another plot of the function G, but between -1 and +1 in the color green. So I'm using various options of the plot, and I have created 2 things called P and Q. Now notice there's no output from this line, right? Because I've just assigned this plot to the name P and this plot to the name Q. Now if you type P plus Q, what is going to happen? So what just happened here, think about it. This blue thing, that's the default color, that is P. And this green thing is Q. It has plotted both of them. So that each plot itself is an object, and you can add objects, which just means superimposing those plots. Okay. If you want more variable, if you want to use like, if you want to use more variables, only X is given for free. But if you want to use Y, then you need to define it. It's not automatically given. Let's see if, but U and V seem to be given for, oh no. So this is a bivariate function. I have defined it as f of U comma V is U plus V into U minus V. So, so let's see if this works. Yes, this worked. And now there are 3D plots as well. So again, what you can do is you can try to look at the documentation for plot 3D by just typing here, so plot 3D and shift enter, and it gives you the documentation. So F, a symbolic expression of or function of 2 variables. There is a U range and V range. So U min, U max, V min, V max, because now it's a function of 2 variables. And there are many options here. And there are examples. So this is a bit funny here, this thing called lambda. Maybe we won't talk about that now. You define your function f of x y to be x squared plus y squared. You give the u range to be -2, 2, and the v range to be -2, 2, and then it will create the plot. So you can try, you can just try copying these examples into your cell and seeing how they work. And there are various there are implicit plots, there are all kinds of things. So let's just see what happens here. And here what I get is a 3D plot, and this thing is actually uses JavaScript, and it's something you can manipulate. So I can see this from different angles. The function I defined is actually u squared minus v squared. So as expected, it's a saddle, and I can view this saddle from all different angles. And this is very useful for helping students to visualize. And you can in fact export this in various formats. This HTML is a bit tricky because you need to get various JavaScript libraries and so on. But anyway, it's possible if you're a little technically savvy to export this and put it on a website. So, okay, so that's the basic things about creating functions and plotting them. Of course, one can go on for days, talk about various features, but let's just move on. So, Sage can do calculus. Uh, So for example, I have already defined this function f. What was f? Now this has overwritten the old function f. Okay, so now if I ask what is f, uh, so if I ask what is f, then it will say it's a function which takes u comma v to u plus v into u minus v. And I can differentiate f with respect to the variable u, simple thing called diff. So diff f comma u differentiates f, takes a partial derivative. By the way, here this thing I have here, this hash partial, this is just a comment. So everything after a hash in any line is going to be ignored by Sage. You can use it as a comment. So now if you look at diff fu, it's the partial derivative of f with respect to indeed u squared minus v squared. So it's 2u. And you can do integral. And hey, it's formally integrated, this thing. It's not numerical. And I don't know, so as in class 12 we had to do lots of integrals by hand, and now Sage can do this. So integral 1 over 1 plus x squared with respect to x, Sage knows that it is arctan of x, so that's pretty cool. So this is much more than numerical calculation. This is symbolic calculus. Something like this was very popular in school. You'd give 1 over some quadratic form and integrate it with respect to x. I'll say, and it can also do definite integrals. So this last one here, I have given the function 1 over 1 plus x squared. Then I have given x. That means that's the variable with respect to integrate. And I have given minus 1 to plus 1. So that would be the range. And hey, this is very surprising. It actually knows that it is half pi and it doesn't do it numerically. So it computes this thing first and then it substitutes so on. Okay, so calculus. So again, these tutorials on the SageMath website will be great help to get more familiar with these things. And I would urge you to spend several hours today just playing with these various things. So yeah. Okay, so then the next topic that I will touch upon is matrices. So now what we are going to do is we are going to just see how to create and manipulate matrices in Sage. So let me just give you a couple of minutes to catch up. Let's see if there are any maybe for a couple of quick questions. If you're on YouTube, you can just type them in. I should actually, and if you're in WebEx, also you can type them into the chat. I don't quite have the. Let me just see if I can get to the YouTube thing. So any quick questions? If you're not able to, start up Sage and all, those are not issues that we can really resolve right here. So you'll have to. Maybe some help from us and the tutors. I better mute this. Yeah.
Yeah. Somebody is asking that are u and v find variables like
I think what is happening here, so let me try something. We can always experiment. So let's, so suppose I just type u plus v. It seems to be working. So u and v are also defined variables. I never defined them. Yeah. But not everything is a defined. Suppose I type x plus y. Oh, this also works. So yeah, maybe I defined y. let's try. Yeah, so now it says Z is not defined. So maybe U and V are given and X is given, but yeah. So, yeah, any other?
So there are more questions regarding.
Huh.
Yeah, you can see them in chat. Yeah.
Yeah. So can you save a plot in EPS format? Certainly you can. I will explain more about saving plots and so on later on. So, but maybe since you've asked a question, let's just do it. So here's a nice little plot, P plus, or maybe we can just take P here. So, so let me add a cell below this. Okay, so is you can say P dot save, or maybe just save P, and then you can give the a file name, and you could specify EPS, and it will do that. So now I will have, let me just go to that directory and see what happened. Oh, sorry. Where am I? Okay, it's called lecture space one. And there is a file called p.eps. Let's view this. Oh, I should probably use this. So you can also use, you can also use other formats like SVG. SVG is very good for websites and so on. Oops. Yeah, here it is. This is the EPS. Notice it's vector graphics. I can zoom in and there's no blurring of the image or anything. Okay, so, and there are other options when you save. You can specify various options. You can just look at the help for this. And so I could also change this to SVG or various things. And you can also try to just save this image, but that's not so good. I think it gives a PNG file. Is not maybe, yeah, I'm not sure. It may not be vector graphics and so on. Okay, that was a great question. Let's see if there are any other questions.
Oh, hello. There are questions on
Legend,
YouTube
multiple
chat.
ranges. Huh? Yeah,
There are
see
questions.
this legend, multiple ranges, and certainly you can. I don't remember offhand how to do it. We'll have to look at the help. Yeah, and there's something. Let's see.
Question in YouTube chat. So someone
Yeah.
asking that we see step-by-step calculations by Sage.
Why not? I mean, oh, for the integrals.
Yeah, maybe.
Yeah.
Okay.
But
And
if you know the
one
steps, you
more.
can try to simulate them on stage.
Okay.
If you know the steps, you can try to do, like if you had that quadratic 1 over quadratic, right? So then what I could do is maybe I could ask for the partial fractions expansion of that. So such things are possible. So if you know the steps, you can compute most things. If you have a function, you can compute its partial fractions expansion. Yeah. Any other questions?
There is one more question regarding that if I wish to do VS Code, then how can I install SageMath? I think installing regarding question can be taken in tutorial, fine?
Yeah. I don't know the answer to that either. So, yeah. Then yeah. So can we do complex integrate this thing? I don't know all the things that can be done in Sage. It's a huge list and it keeps changing with every version. So you should look at the documentation for any specific thing that you want. How to use the Jupyter notebook through Sage Terminal? I think I said that. You can say Sage minus n Jupyter, or you could, I think, once you're in the terminal, you could say notebook. So let's try this. So so I could say Sage minus n Jupyter. Sage minus n will probably do it, or Sage minus n Jupyter. But if you're in Sage, I think you can just type notebook and it will give you the notebook. So just type note. Is it still there? Not sure it's still there. Okay, so there used to be something. No module name. Okay, so yeah, I'll have to look this up. I'm not sure exactly. Once you start a Sage session, but you can start it in the notebook, in notebook mode. Okay. Yeah, and can we save 3D plot after? Yeah, so that Ayush's question, that's what I was saying. I tried to do this yesterday, and it involves a little bit of there's this export save as HTML option. But when you save as HTML, it needs certain JavaScript libraries to run. So you will have to figure out how to get those and so on. To manipulate the picture and so on. So it could be a little bit of a headache, but you will get an HTML file and it will ask for various scripts. So those need to be installed as well. So if you know a little bit of JavaScript, you can probably do that. Okay, are we pretty much? Yeah. So again, one of the homework problems today is to take any topic of your choice once you've solved the other few problems, and then just go through the documentation and play with it. So if you want to know how you can use Sage in functional analysis or something like that, you can just easily you can easily just look at the documentation. I only know certain areas of Sage, mainly those which are related to combinatorics, group theory, maybe some graph theory. Um, so yeah, it's a huge project with 1,000 plus developers and so on, and people don't even know the breadth of it. So, okay, so let's do the other basic thing, which is matrices. I mean, I'm just going to pick a few things, which I feel that most people will definitely need today, for today. And so the other thing is calculus and the other thing is linear algebra, especially for teachers. These are the two topics which definitely, we would like to use something more to give our students a feel for things. So you can create a matrix by just typing in the entries. And now again, we use these square brackets. So each row is enclosed in square brackets. So that's a list. So let me just slow down here a bit and explain a bit about lists. So if I enclose something in square brackets, it becomes a list. Okay, so 1 comma 2, this is a list. It has two elements, 1 comma 2, and I can have a list of lists. So I can have a list 1 comma 2 and another list 2 comma 1, and now what I have is a list of lists. So it's nested, and it shows like this. And a matrix, the most basic way to create a matrix is to give a list of lists. So here I have uh, created A as the matrix 2 comma 1 1 comma 2, and then I have used this print command to print it. So you can look up the help for matrices, which is quite extensive. uh, is this thing muted? That's muted. Okay. So yeah, so here's the thing. So I've created this matrix. Now this is a slightly new thing. I say you would want to say inverse of A. Okay, but there's no inverse in Sage. So how would you find the inverse of a matrix? So the reason there's no inverse in Sage is that specialized thing. You can't apply it to a number. Usually you don't anyway, but you do apply it to a matrix. So this is a new way of having functions, which is this function is bound to the matrix. So inverse, I can type inverse and then put open close parentheses. So let me just explain this construct. So what is this new thing, A dot inverse? So the thing is, this function inverse is what we say is bound to the matrix. It's tied to the matrix A. And so we do not provide an input to it. It is assumed that the input is the matrix A itself. Okay, so don't worry too much about this, but just note that for somewhat specialized functions which apply to only one class of objects in Sage, usually the functions are provided by dot and then you type the thing. So, for example, if you have a matrix A, there are many, these are called methods, okay, these bound functions. There are many methods associated to a matrix. Act on add multiple of column, add to entry, additive order. God alone knows what half these things mean. But some of them, Cholesky must be Cholesky decomposition. There are things column module. So you can find all these methods by just typing a dot and then tab. You press tab and then it shows you all the possible methods. If you kind of know what you're looking for, you can type the first 2 or 3 letters and it will give you possible completion. So I typed IN and then I pressed tab. So it said indefinite factorization index. Here's inverse. So if I click on it, and then if you want help on inverse, you can now press question mark and it will give you help on it, including examples. So you can just copy one of these examples and so here m equals matrix m. So there's also this m to the power -1 which seems to work. So but you can use this dot inverse. So, but then you need to put open close parentheses. If you do it without open close parentheses, that inverse is a built-in method. So you're looking at the function and not at the value of the function. Now you're looking at the value of the function. So that's bound methods, which we'll see a lot in Python. So other bound methods for matrices are minimal polynomial. So the minimal polynomial of the above matrix is x to the 4 minus 4x plus 3. You can give eigenvalues. And you may want to give some additional arguments. So I want to take A and delete rows. So here's my matrix A. It's 2, 1, 1, 2. And I have, if I type A dot, see, if I look for the method, there's something called delete rows. Okay, so let me try this. So this is part of the experimentation. So I say question mark, and it says return the matrix constructed from deleting rows with indices in the D rows list. So what is D rows? List of indices of rows to be deleted from self. So self here, when you have a bound method, the thing to which it is bound. So self here refers to the matrix A. So A dot A matrix, they've constructed a delete row 0 and 2. So it has taken this 4 by 4 matrix and deleted the first row and the third row. So this here we said 0 and 2. That's because in Python, counting always begins with 0. So you don't start counting with 1, you start counting with 0. So the first row of the matrix is row 0, row 1, and so on. It's a bit confusing at first, but you get used to it. So here, let's try this. Where would we? A dot delete rows 1, and it oops, क्या हुआ? Let's see. A is this matrix. A dot maybe. Do I have to give a list of rows? Yeah. So I have to give a list of rows. So it's maybe because I'm using delete rows is a plural here. So I gave a list with only one element, namely 1. So it deleted the row number 1. I could try deleting both rows 0 and 1, and then it should give me an empty matrix. Yeah, there you go. And if I try deleting row 2, I'll get an error because it will say index error. So okay, let's just delete the first row. So that's delete rows 0. So, but here, okay. I think there's also something called delete row. I'm not sure. No, there's nothing called delete row. Okay, so delete rows 1. Don't feel scared to experiment. Most that will happen is you'll have to restart your Sage if it crashes. But okay, and yeah. So now what is this A plus B? There's no matrix called B, but I think when I had prepared this, I had something called B. Let's say B is A inverse. B equals A dot inverse. And then I can add matrices. I can do various expressions, A plus B into A minus B, determinant of A plus 2B. I can do characteristic polynomial of and so on. And okay, so how do I access entries of a matrix? So Aij, that's the format in square brackets. So A0, so let's just recall what is the matrix A itself. So let's so A is the matrix 2, 1, 1, 2. So if I type A0, 0, I should get 2 because it's the thing in the 0th row and 0th column. So I should get 2. A01 is in the 0th row and first column. So that should be 1. And A10 should again be 1 and A11 should be 2. Okay, so here I am just reiterating what I had said earlier. To find the list of methods available for an object A, try typing A dot and then pressing tab. If you know the first few letters of what you are looking for, you can type them and then type tab. For example, if you're looking for information on tensor products, you can type A dot and then try, okay, maybe tensor. So I'll try 10. Then I have something called tensor and I have something called tensor product. I can look at the help and returns the tensor product of two matrices. Okay, so it's bound to A. So probably I should give the second matrix as an argument. So M1 dot tensor product M2 will give you the Kronecker tensor product of the matrices M1 and M2. So for example, here let's get rid of this. B equals A dot tensor product A. So this will give uh, yeah, so let's just see what B looks like. So B is this 4 by 4 matrix obtained by taking this 2 1 1 2 and tensoring it with itself. So you see this is 2 times the matrix 2 1 1 2. This is the matrix 2 1 1 2. This is 2 1 1 2 and 2. So this is the matrix whose entries. So this is here it's given as a block matrix. Okay, and so this is now my B, new B. The old B has been overwritten with inverse of A. And I can get, so now you can see how to form sub matrices. Let's just look at this. B 1 colon 3 comma 1 colon 3. So what is going on? It's giving me the row numbers 1 to 3, which means the second row and the row number 1 and the row number 2. 3 is avoided. So this we'll see more about these kind of things when we um, study lists and slicing and so on. But this is a row slicing and this is a column slicing. So 1 colon 3 means starting with 1 and ending before you reach 3. So 1 and 2. So this is the first, second and third rows and second and third columns. But if I type 1 comma 3, then it's showing the second and fourth, 4 2 2 4. Okay, so this colon and comma are different. Anyway, you'll get used to this a bit. So maybe this is another good time to stop for a few questions and so on. Let me see if there's anything on the YouTube. There's some lag on the YouTube.
Yeah.
Yeah. Yeah. So Muhammad Ibrahim Sheikh has a very nice question. Is it possible to find the number of homomorphisms defined from one group to another? I think it might. I haven't tried it. So Sage uses gap for a lot of its group operations. and most of the things that are available in Gap are available in Sage, but there are also things which are not available in Gap which are available in Sage. So whatever you can do in Gap is possible to do in Sage, but you can also take advantage of Python programming and things like that.
I think as far as group homomorphisms are concerned, they are not available in GAP as such, but you can define homomorphism using images and all. Definitely, you can find isomorphisms and you can find automorphisms using GAP.
But don't take anyone's word for it. Go and check on the
Yeah, go
documentation.
and check. Yes,
Yeah, yeah,
that is my knowledge as far as I
yeah.
remember.
So Arijit Kumar has a question, is this similar to Mathematica? Is yes, then what is the difference between them? So yeah, so Sage is supposed to be a replacement for Mathematica. What is the difference between them? Uh, so Sage is open source. You can see the source code of Sage, and if you don't like something about it, you can change it. You can contribute to Sage. Everybody is welcome to contribute to Sage, and it is free. So that is one advantage of Sage over Mathematica. You don't need any. You don't need to be rich to use it. The other thing about uh, the other thing about Sage is that it uses Python, so it's very easy to program in for Sage. It's better than the language of Mathematica. There's a lot of, if you want the full list of advantages of Sage, for instance, you have these very powerful Python libraries, NumPy, SciPy, for numerical computations. Then you have Matplotlib, Simpy, Maxima, Gap, Flint, R, and so on. So none of this is easy to use from Mathematica, but they are just fully integrated into Sage. And one of the things I've found really nice about Sage is that using Sage, you can club many different softwares and use them together in a seamless manner. So yeah, Sage is in some ways similar to Mathematica. Some people actually still prefer Mathematica, but I think by now Sage is well developed enough to be pretty much strictly superior to Mathematica in most aspects. So Wolfram needs a new business model. Yeah, let's see any other questions. Okay, so yeah, so I don't get what is this tensor operation and matrix. Can you please explain it again? Okay, so Pooja, how do I clear out the page on Jupyter Notebooks? Okay, so in this Jupyter Notebook, yeah, it takes a little while getting used to it, and I actually don't use it so much. So you can go to this, there are these edit, you can cut cells, you can delete cells, you can split cells, whatever, insert cell above, cell itself, you can run a cell, you can restart your kernel, that is, refresh everything and start again. uh, then I don't know what these widgets are, and then there's a help. So if you like to do things with the keyboard, there are keyboard shortcuts which I find very useful because I'm sort of very slow with finding things in menus. There's help on markdown, and then there are all kinds of tutorials also available right through the um, notebook interface. You may want to look at Matplotlib if you want to plot things. It's a Python library for plotting, and it's everything is available in Sage. So yeah, how are you getting writing space? So how am I getting writing space above and below? I happen to remember. Let's see. Where did it go? Okay, here in the help, keyboard shortcuts. So command mode. So command mode is so let me just show you command mode. So now I'm editing this cell, but I want command mode. I press escape and this thing turns blue. Now I'm in command mode. And let's go to the help again. So in command mode, there are various keyboard shortcuts that are available to you. F is find and replace. Control Shift F is open the command palette. You can try to fool around with these things. Uh, So change cell to code, you press Y. Change it to markdown, you press M. And then various headings, you can just use markdown for that also. Insert cell above is A. Insert cell below is B. So that's what I've been using to create new cells above and below. But I think you can just use this edit. No, insert, you can use this. Insert cell above, insert cell below. Okay, let's see what other questions are there. Can we construct specific linear codes in SageMath like we do in Magma? I haven't tried doing that. You'll have to. That's a good. You should look up Sandeep. You should look up the documentation and see. Certainly, you can create subspaces of vector spaces over a field with two elements if that's the kind of thing you're looking for. But I'm not sure exactly what functionality you need here. So I haven't actually done this in Magma either. So yeah. Let's see, are there any questions on the other window here? How to write my own code and run it in Sage? Great question. And how to write my own functions and use it? Great question. So I'm just coming to that. So let's move on. I think I have something about. So we are done here. Forming submatrix. Yes. So saving your work in files. So as I said, you can save plot to EPS file, and you can also save a matrix itself. So this matrix A, I can save as a file. The file extension is SOBJ. So that's a Sage object, and it is some mysterious thing. It will save it in that format, but then I can load it. So you can look at the help for Sage. Again, the help, if you're new to this, may be a little hard to read and so on. So better to look at some internet fora and so on. But basically, whatever thing you want to save, you give the thing you want to save, and then you give a file name. And from this file name, it will kind of try to understand what you want to do. So this here P was a plot. And when I say save it as in an EPS format, it will just save the image, the picture as an EPS format, and then you can use it in your in whatever article you're writing or whatever. Here, what it's doing is it's saving it as a file called SOBJ. So I have done some really complicated calculation. I save it in a Sage object file, and then later, maybe many months later or many years later, or you email it to your collaborator or whatever, and they can just load the object again. And now you can look at this. This B is now what was the matrix A earlier. I had saved it to this file, and then it's read the file again. And this file will be in the directory where you're working. You can give if you want, you can give an absolute path for the directory. So you can give a, something like, I'm using Linux, so I'll have this user slash amri slash whatever. You can give the absolute path, or you can give a relative path. Okay. Code can be saved in a .sage file and then loaded into a session. So let's just look at this. So here I have a file called matrix.sage. So let me just show you what's in this file. And this file has just 2 or 3 lines of code. Let me make it a little bigger. So it has a matrix. A equals the matrix 3 2 1 2 1 3 1 3 2, and B is the matrix A squared plus A plus 1. And it also says print B. So this is a file in that directory, and it's called matrix.sage. So let's just go back here, and let's say load matrix.sage. So what do you expect will happen? Well, if you look at this file, what will happen is it will print the matrix A squared plus A plus 1. So let's see if that happens. It has printed this matrix. This is presumably the matrix A squared plus A plus 1. So you can write your code in a .sage file, and then you can just load that into your session. And all the things that you have done will now be available in your session. So A is now this 3 by 3 matrix, B is now the A squared plus A plus 1 matrix. And again, you can give a complete path, relative path. So for example, here the complete path is home, Amri, my files, teaching, Sage, lecture 1, matrix dot Sage, and that still works. Okay. So that is more or less in an hour sort of getting you started. But the most important thing is reading the documentation. So you need to be able to read the documentation. The only way you can learn about Sage. Um, no number of workshops and so on will get you working. So you should have some project, some small project which you want to do. Maybe your project is to develop a module to help teach your students calculus using Sage. So then there are various you'll find even tutorials, you'll find textbooks. If you go to the SageMath Works website, let's see, there are books on group theory, there are books on so this, for example, by William Stein. William Stein is the founder of Sage, and oops, there's a huge list here. So there was this book on elliptic curves by Williams, I think, which is a beautiful book. Cremona's elliptic curve database here, but I think, well, the 39 search results for elliptic curves. Anyway, so there are lots of nice, there are papers, there are books uh, using Sage. So let's just go up here. Yeah, so public citing Sage. Articles, you probably don't want articles, maybe you want books. This should show us books, right? Books, yeah. William Stein, Modular Forms, A Computational Approach. Beautiful book uh, about modular forms. You learn about modular forms and the whole subject becomes much more concrete because you are able to take these things and play with them. And I think for me as a mathematician, this is very important that when you learn some concept, you should be able to play with it. And Sage makes that relatively uh, easy. There's a book here which I haven't seen before, Sage for Newbies. That sounds very reassuring by Ted Koser. Uh, so lots of things. Sage tutorial, of course. Granville and David join a differential calculus and Sage. So some of these are actually designed for teaching. So you could even take one of these books and try to teach out of them. With this introduction to cryptography, I wonder if there's coding theory. So yeah, so David Joyner and selected unsolved problems in coding theory. Okay, that's only one in coding theory. Maybe there's something in error correcting codes. Oh, these are articles, so these may be more arcane. Anyway, so that's there's extensive resources out there, and everybody is welcome to contribute. So there's a whole community. Sage is developed by mathematicians and teachers. So whoever is using it is developing it. So it's very responsive to the needs of the community. And for me, I find like very specialized things that are there in Sage, which you will not find in any commercial software. So, and if there's something you don't you want but is not there, you can contribute it if it is of some interest to people. So that's yeah. So now Sage is organized in modules. So the basic thing is Sage, and then there are many sub modules in Sage. So Sage, you can explore Sage using this thing. So Sage, I am a lot interested in this module called Combinat. And then if you look inside Combinat, so this is a module. Inside this are sub modules. So there's abstract tree, affine permutation, Cartesian product, cluster algebra quiver. So you can just go through this. So there's a, let's look at here's some integer vector, and then you can just type this question mark, and it will give you the documentation for integer vector. You can also find this in the Sage documentation. So let's see. And inside integer vector, what is there? So there are there's a class called integer vector for constructing integer vectors and so on. So you can sort of go down these different rabbit holes and look for whatever it is you are interested in. But maybe this, for this kind of thing, it's easier to go to the Sage website and look at. There's a tour. Then, yeah, there are, yeah, overview, and you can find. So there are the documentation on specific topics like basic algebra and calculus, plotting 2D and 3D, basic rings, univariate and multivariate polynomials, some very powerful algorithms here, linear algebra, finite groups, um, and there's something called advanced mathematics in SageMath. So you can in fact pick one of these if you want, and try to see what are the things that are available. You'll find some pretty stuff is available. And I find the easiest way to find documentation is to type in a search engine the word Sage Math followed by whatever I'm looking for. Okay, if you type Sage, then it's not so good because there are lots of things called Sage. But if I type Sage Math and I try to type graph isomorphism, then using Google search, for example, then I get lot of search results. So here's the Sage HTML web page on undirected graphs. So there's a Sage reference manual. It's all online, and you can yeah. So that's so on graph theory. This is the manual on graph theory. It has a databases. It has all kinds of things and constructions for directed graphs, bipartite graphs, various things. So you see spanning trees, whatever you like, pretty much everything should be there. So if you go to the main root page of the Sage reference, so this is SageMath dot yeah, so reference manual. Then it starts with very basic user interfaces, graphics. Um, yeah, so rings and fields, linear algebra, calculus and analysis, probability and statistics, mathematical structures, discrete mathematics, number fields, function fields and valuations, number theory, algebraic. So just look for whatever it is that you are interested in, and hopefully you will find what you are seeking. If it's not there, then well, it's an invitation for you to try to contribute to Sage. Okay, so I will stop babbling now and see if there are questions. Random it. Okay, so you can ask more questions. Yeah, so using Sage in Anaconda, I don't think it can be done. Uh, if you so the way it usually works is you install Sage and then you get Python in it. So I have a separate Python and I have separate Sage, and I can use Python from Sage, or I can use my other installation of Python which is needed for various other things. Um, Anaconda will not support Sage. Um, so ZZ represents integers. It's the ring of integers. How to define matrix over finite fields? Great question. Let me just show you. So, so let's define a matrix. So let's look at the help for matrices. So that may help us. Yeah. So matrix. Okay. So that's the most basic thing. There's matrix dot identity matrix and whatnot. You just scroll down. Here's something. Matrix QQ 1 2 3 4 5 6. So this will be a matrix whose entries are in the ring of rational numbers. So I have these are integers, but now this will force them to be thought of as rational numbers. What is this matrix 3? So this means that it's a 3 by 3 matrix, and this lambda is some sort of way of specifying the entries in terms of I and j. So you saying that the ijth entry is I minus j. QQ. Okay, so you can specify the field as the first argument, and then you can specify the size optionally as the second argument, or you can just, so let me show you construct a matrix over a field of order uh, 5. So I will say, I think, let me just see, I think there's something called GF5 is a finite field of size 5. So I'll specify that my matrix is over the field of order 5. If it was a field of order 25, I'd have to figure out how to write down elements in that field firstly. And then I can put in, 122, 3. I need a list of lists. So let's try something like this. -4, comma 7. And let's see. Oops, I should have removed this question mark here. Yeah, so this has put my matrix inside GF5. So let's call this matrix A, and now it will treat this matrix as a matrix inside GF5. So A, if I ask for determinant of A, it will give me the determinant in GF5. So the determinant of this matrix happens to be 1. You can compute the inverse, and it computes the inverse in GF5. So yeah, you can definitely define your matrix over whatever field you like, and then it just does everything over that field. So characteristic polynomial is also over the field of. Okay, so in loops and so on, I will talk about more next time. But what you can, maybe I can just tell you real quick if you're so loops. Loops are a bit complicated, so we don't use counters like in most other languages. We use what are called iterables. So let's do that next time. Uh, So indentation is what if you when you write a loop, you indent it, and then you unindent when you're done with your loop. So that should answer Sandeep's question if you already know a little bit about loops. But I'll do loops in detail next time. Okay, let's see if there are questions on the. Okay, how to create a new module dot submodule in Sage. So, okay, so usually you will not be in the beginning stages. You will not be editing the source code of Sage, but you can edit the source code of Sage and insert new modules into Sage. So Sage uses Git, so that you can create your own branch of Sage, and then you can create your own modules inside that. So for this, I would recommend that you read the Sage Developers Guide. So you can in fact create and maintain your own branch of Sage. And every time there's a new branch of Sage, a new version of Sage released, you can merge it with your branch, which has the specific things that you want. So you can have your own personalized Sage. I have such a thing floating around somewhere, and it has some algorithms which, well, it had some algorithms which only I had, but Sage didn't have. But then subsequently, Sage implemented most of those things, and so I no longer maintain my own personal Sage. Uh, yeah. So you can definitely do this. Look at the Sage developers guide, and you'll be able to do it. You'll have to build. You'll have to build Sage for that. So you cannot just download binaries. Okay. Yeah, Sridhar's trying to answer the indenting business in the comments, but it's a little difficult to see. So let me just show you. What's it called? Yeah. Let me just show you, or maybe I should do it in the notebook. So, so here's, so this is an example of a loop. So this will give us I going from 1 to 9, 0 to 9, and then I indent 4 spaces, and then now if I want to exit the inner loop, I will unindent 4 spaces. We'll talk about this in greater detail next time. So what is happening is, it's after every time it runs the inner loop, it goes to the outer loop and it prints outer loop. So okay, so this is how. Unlike JavaScript or C++ or C, we don't use so many braces and things like that in Sage. We just use indentations. So it makes the code easier to read. This is Python. Yeah, so Sandeep, you can look at this example I have here. I'll share this. I'll share this worksheet on the forum and on the in the notebook. Maybe Dilpreet can put it on the website also. So, so I'll do that as soon as we end this session. So if you want to end all the loops, you just unindent fully. So now, right. Now this is outside the loop. So you may want to take Python tutorials. I will explain the basics of Python in the next two lectures, which will maybe be a little bit faster than this lecture. But there are many, Python tutorials. I think W3 Schools has Python tutorials, which are very nice. I learned Python by taking an online course somewhere. I don't remember. I just took 1/3 of the course, and by then I knew enough Python to figure out the rest myself. So just there's a learning curve. Initially, it's a bit hard, but then Python is really the easiest language. One thing that you should note about Python is that you don't declare variables; it's dynamically typed. So if you're used to JavaScript or C++ or whatever, it takes a little while to unlearn those things. It's interpreted, so it's a little slower. But the whole idea is to use libraries which are written in C++ uh, or C to get through Python. You only do the high level stuff here. Okay, let's see. What else? Oh, okay. More questions. We do not use an end. Yeah. We do not use, yeah. How to find submatrices of a particular order of a given matrix? Good question. let's see. I don't know the answer, but let's see if we can find out. So I had this, let's see, do I have some nice matrix? What is this? B. Yeah, B is a 3 by 3 matrix. So let's see, B submatrix. It has something called submatrix, but it doesn't have submatrices. So maybe to do this, you will need to do a little bit of coding. You'll have to find all subsets of the set 0, 1, 2 of whatever size, and then, list the submatrices. So that would involve a little bit of Python. Uh, it doesn't seem that there's a built-in thing for enumerating all submatrices of a thing. That's very useful. Sometimes you want all I by I minors of a matrix. So then you have to actually program it to list them. Let's see. Uh, yeah, we do not use end no, we don't use end for a for loop. We just indentation decides everything. Yeah, so basically you need to yeah, Simran, you need to find a list of all combinations of the columns. So there's a library called iter tools, which is very helpful. So I know this. So for these kinds of things, I can import from iter tools something called combinations. And then so I have a say I have a 5 by 5. I want so I have a set of size 5. So I'll use range 5. Okay, so this will give me so it doesn't it's not very helpful. Maybe this will be a bit confusing for most of you, but range 5 gives me the number 0, 1, 2, 3, 4, 5. Okay, and now I use combinations range 5 comma 2, and this will give me, okay, this again I need to say list to display all these things. And this has given me all the subsets of size 2 of the set 0, 1, 2, 3, 4, 5. So using these kinds of tools and loops and so on, you will be able to get all your submatrices. Um, so maybe you can spend some trying to figure this out. I will explain some of these things next time. So this maybe you'll be able to definitely be able to do this tomorrow. But you can try to figure this out today. If you're already slightly familiar with Python, then this should be okay. But if Python is completely new to you, then this may be a little tricky. So let's see. Any more questions? What about on YouTube? Yeah, so I will be doing 2 lectures on Python. Next 2 lectures will be basic Python. I mean, Sage is basically, Python. And Ranjit, to find the syntax for things, you have to look at the documentation. And so one is to, go to the Sage website, and the other is to use question marks and so on. And you could also use a search engine. So you will find, yeah. Okay, did I miss out any questions? I guess I have everything, right? So, wow, 1.5 hours just flew by. Okay, let's, yeah. Let's stop for now. You have, I'll share with you the worksheet which we generated in today's lecture. And then I will also share with you files for the assignment. So for the assignment, I'll share with you two files, something which you have to load. And so what you should do is you should install the Jupyter notebook and the file in the same directory, and then you run Sage there. Or you can do this in your CoCalc thing. I'll also share it for those of you who have registered for the tutorials. We had to pay for the accounts for the tutorial, so we had a somewhat limited thing there. I'll I'll share with you those worksheets and so on CoCalc itself. So all that should be done within 15-20 minutes of this of now, hopefully. So that's it for today's session.
Thank
Um, yeah.
sir. Okay. Sir, can we share calc sheets via online SageMath group as well?
They're not CoCalc sheets, they're Jupyter worksheets. They are just files. We can share them. There's no problem.
Because all of them are
Yeah.
not added to that co-calc.
So Dilpreet, I'll send you the Jupyter. I can post it on the forum, in fact.
Yeah,
Uh,
yeah, you please.
yeah, and I'll also send. You can also share them on the website. Some people said they have trouble getting onto the forum.
Okay.
I don't
So
know why, but because the
yeah,
forum should be open to
so
anyone.
I
So
added 500 people manually yesterday. Then I got
yeah,
message that I can't add more. I'll add remaining 170 around people today. I'll
okay.
do it in next 15-20 minutes.
Okay, so I think we have a lot of things to take care of now in the
Yeah,
next
yeah.
15-20 minutes. So let's,
Yes, yes.
yeah. And
Okay,
it was a wonderful audience. It's been great fun. So I'm looking forward to tomorrow as well.
okay.
I may not be around for the tutorials and so on. So
Okay, no
I'll
problem.
see you tomorrow.
Okay.
Okay, thanks.
Thank you
Bye.
very much. Bye, everyone. I'm going to end this meeting. So see you tomorrow at 10. Bye.